So go ahead and copy down this example. We're going to talk about how to figure out if two functions are inverses. So on yesterday's lesson, you had to do two compositions. But now we're going to do our compositions. And as long as it's equal to x, that means that our functions are inverses. So I'll give you a minute to copy that down. And then we will show that these two functions, f of x and g of x, and these are pretty basic ones, will show that they are indeed inverses. We're going to finish 5.2 tomorrow. Thursday, you will have, I'm not sure yet because that's the PSAT. So I only have my juniors in this class. So I'm not sure. I think we'll be okay. And then your quiz is actually on Halloween. So you have a chapter 5 quiz October 31st. So we're going to do two compositions. I see a lot of people who got F's on the last test with their phones out. That's not a good idea. We need to lock in, y'all. Or D. Okay. F or D's. Okay. So, all right. So we're going to take our G of X, which is here. And I'm going to put it in for F of X. So if I'm trying to find F, and then I'm putting my G of X inside. So that my F function says 3 times X. So that would be 3 times my input. And the input is G. Notice that when you multiply these two numbers together, 3 times 1/3 is 1x. So it does indeed simplify down to 1x. Now let's go the other direction. So now let's find G. And I'm going to put my f of x inside of G. So I'm going to take this and put it this way. And you're going to have to show that on your quiz. Even if you can look at it and know that they are inverses, you still have to show both compositions on the test. Yes?
So how come you don't put like, because on the video you showed you put like, the F.
Can you say that one more time?
Like on the video, like how come we don't put the 1x in, are we going to put it in for the...
What?
Because I couldn't hear what you were saying.
So what we're doing, so on the video yesterday, what we did yesterday was we just put f of x inside of g of x and simplified it. That's what we did in the video, if you watch it. The beginning, we just did numbers. And then I think, if I remember correctly, we did have a couple equations where we had actually just functions. Okay, so now what I'm saying is when we do our compositions, if they are inverses, it will equal x when it's simplified. That's the definition that I had you write down here. That's the definition of inverses. The definition of an inverse says that if you put G into F and it simplifies to X, and conversely, if you put F into G and it simplifies to X, that they are inverses. All right, so my G function says 1/3 times X. Go ahead and put your F function on the inside, and this simplifies down to X. So because they simplified down to X, then I know, yes, F of X and G of X are inverses. So that's what you'll have to show me on the quiz next week.
So the quiz on Halloween.
as of now. All right, go ahead and copy down these next two. So take a minute. Now these are a little bit harder. So take a minute and copy down these two. You don't need to copy down this definition again because you should already have that. You should only need to copy down example 6. So go ahead and copy down. And we're going to also show that they're inverses. I didn't change it. Yeah, no, I didn't. Okay. All right, so this is a little bit more, has a little bit more to it. So again, the first thing I'm going to do is write my f of x function. So I have my f of x, and then inside I'm putting g of x. So f of x says 5 minus 2 parentheses. Now inside of the parentheses, what am I going to put? Inside of the parentheses, we're going to drop in, yep, this right here. So I'm going to put that whole thing on the inside. So I have 1/2 and then 5 minus x. So the first thing I'm going to do is multiply the inside. I'm going to start by distributing that 1/2. So that would be 5 minus 2. So now I'm taking 1/2 times 5. What do you think 1/2 times 5 is? 2.5, or you could put 2.5. I would put 5 over 2, but that's the same thing. 5 over 2 minus 1/2 x. Now you're going to multiply the -2 on the outside. So take -2 and multiply it by 5 over 2. And then take -2 and multiply it by 1/2 x, by -1/2 x. And there is a question like this in your homework. So -2 times 5 over 2 would be what? -5. And then negative times a negative becomes a positive. -2 times -1/2 would be 1x. And then what's going to happen with the 5 minus 5? So I'm left with an x. So you have to show it. Even though it is going to equal x, you have to show me how it simplifies down to x. So now let's go the other direction. So now let's take the f of x function and put that into g of x. So I have my g function. I'm putting f of x on the inside. So I'm going to take this and put it in here. So when I write it, hold on, let me give myself some more space, okay? So when I write it, I'm writing my, my g function with parentheses. So that would be 1/2. And then 5 minus, and instead of x, put a parentheses. Now inside of the parentheses, put your 5 minus 2x. So the first thing you're going to do is distribute that negative. Go ahead and distribute. There's an invisible -1 in front of the parentheses. So who had that? Yes.
So it will always ask us to show that they are inverses rather than see if they are inverses.
That's a good question. I have to check and see. It could say show it, or it could ask you to prove it. So yeah. So now we're going to simplify the 5 minus 5, which is 0. And that leaves me with 1/2 times 2x. And what is 1/2 times 2x? 1x or just x. So the answer would be yes. F of x and g of x are inverses. So Jaden asked a good question. I don't know if the quiz is going to give you two functions and ask you to show that they're inverses, meaning that it could not simplify down to x, or it could be asking you to verify it. So the main thing is know that if you put one function inside of another function and then it simplifies down to x, then that means that they are inverses. And that is the end of 5.1. Any questions?
No, ma'am.
All right, draw a line and let's start 5.2. So 5.2 homework is due on Friday. That's 5.2 homework. I really shortened it down a lot. All of the homework is less than 10 questions. So that's homework 17. And I got that from Canvas. So if you're titling your notes, this is the title. And you're actually going to glue that down. So I probably should have said that first. The thing that you picked up after you title it, go ahead and glue it down. Because the first thing we're going to talk about is one-to-one functions. So the title of 1.2 is one-to-one and inverse functions. And then the cutout in the front, go ahead and glue that down. So on that cutout, there is at the top the definition of one-to-one functions. So we talked about, is it a function? Remember, for is it a function, you could not have any repeats in x. But for it to be one-to-one, according to our definition for one-to-one, no repeats at all. No repeats. So x cannot repeat and y cannot repeat. So go ahead and look at example. For example 1, it says determine if they are one-to-one. So I'm going to zoom in. Remember, you're looking, it can't have any repeats. So we got to look at our x's. All of our x's have to be different. And our y's have to be different. So if any of my yellow numbers are the same, it's a no. If any of the blue numbers are the same, it's a no. But if your x's are all different and your y values are all different, then it is one-to-one. One-to-one means that it has no repeats. So what would you say for A? Would you say yes or no?
Yes.
Yes. So this is one-to-one. I would agree. All right, now let's look at B. I'm going to have you all look at B and C. Don't say it out loud. but just write yes or no for B and C. And if you see a repeat in X, then you don't even have to check a Y. It's automatically a no. And if something repeats, circle it. So who would say B is 1-to-1?
No.
Raise your hand if you say yes. Who says no? All right, where's the repeat? 8. So this is a repeat. So that's a no. What about C? Who says yes? Who says no? All right, where's the repeat? 4. So that wouldn't be a function or 1-to-1. So that's a no. When you're looking at a map, oh, we got one more. We got D. Sorry. Go ahead and look at D. Don't say it out loud, but look at D. Who would say yes? Who says no? All right, what repeated for us to say no? The 2 in our Y values. Here and here. So that would be a no. So that's the first question on the quiz. You have a set of ordered pairs, or it could be a map, or it could be a graph. Now, that's A, B, C, and D. Now let's look at E, F, G, and H. So when you're looking at a map, if you have 2 lines coming off one point, that means that there is a repeat. So this tells me, because there are 2 lines coming off at this point, that E repeats. So the letter E, so is BE is a point and CE is a point. E repeats. So that's why E would be a no. That's a no. All right, what about F? What would you say, yes or no?
No.
All right, which one repeats?
A.
A. So you have the point AD and you have the point AE. So this is a repeat, so that would be a no. Go ahead and look at G and H. All right, yes or no? All right, what would you say for G, yes or no?
Yes.
Yes. What about H, yes or no?
No.
Definitely a no. A repeats, B has a repeat, P, Q, and R, they all have repeats. All right, so now let's look at a graph, which if yours doesn't say it, this should be J, K, and L. That might have been cut off from your handout, but that's not that important. Now, when you're looking at a graph, it has to pass a horizontal and vertical line test. So in chapter 2, we had to look to see if it was a function. It only had to pass a vertical line test. But now we would have to pass both. Miss Genesis, can you sit up for me, please? Thank you. So looking at this one, only one of them would not pass. Which one, J, K, or L? Only one of them does not pass. Yeah.
J doesn't pass.
J doesn't pass. What does it fail? Does it fail a vertical line or a horizontal line? Horizontal line. So this fails a horizontal line test, so that would be a no. This is a log function that we're going to graph later on in chapter 5. This is a function. So that's a yes. It's not, sorry, it's a function and it's one-to-one. And then this is what we just graphed in chapter 4. That's a rational. That's also a function. All right, so now what we're going to do is practice finding the inverse. So take a minute and copy down these two. Example 2. And we're adding one thing to it, and that's just stating the domain. So this is kind of a continuation of 5.1. We have to find the inverse and then state the domain. And remember, domain is all real numbers if you don't have a red light. And let's see, we'll do 1, 2, 3, 4. All right, so let's go ahead and do our first one. So we are going to take our g of x and put it inside of f of x. So I have my f of x function. Let's put g of x on the inside. So f of x says 3 times x minus 9. Go ahead and put your 1/3 x plus 3 on the inside. Go ahead and distribute. 3 times 1/3, 3 times 3. We actually don't have to state the domain for these two. I'm going to take that off. That doesn't come until tomorrow. So we can take that off. All right, so let's go ahead and verify. So we're going to take 3 times 1/3. What is 3 times 1/3? So 3 divided by 3. What's 3 divided by 3? 1. Plus 3 times 3. 9, bring down the minus 9, and this simplifies down to x. All right, now go the other direction. We only have one more question after this, and then we'll be finished. We have our g, and we put our f of x inside of the g. So when I write my g, which says 1/3 x plus 3, now inside, I need a little bit more space. You're going to go ahead and drop your f function. So put 3x minus 9 on the inside. Go ahead and simplify that. Distribute the 1/3 and combine your like terms. That was good, Tranquil. The beating. It's good. All right, so what is 1/3 times 3x? What did you say? X. What's 1/3 times -9? What did you say, Eric? -3. Bring down the plus 3. And then -3 plus 3 is x. So we can verify that they're inverses. All right, last question, and then I'll show you your test. Deadline to do a retake on the quiz is October 31st. And the deadline to do the retake on the test is, it's the Friday after that. And I'll look at that and I'll put that on the board. All right, go ahead and copy this down. Example 3, we're not stating our domain though. So again, we're going to verify that they're inverses, and one of them has a square root. So we're going to start off by putting G inside of F. So I'm going to write this function right here, and I'm going to put parentheses where there is an X. So I have my first parentheses, and then it's plus 3 squared. Now inside of that, I'm going to put a parentheses that I'll use, and I'll put my G of X in there. So that would be the square root of X minus 3. So you have to show how this simplifies down. Now, because there is nothing happening to X, the first thing I can do is just drop my parentheses, which gives me a square root of X minus 3 plus 3 squared. What do you think goes away next? What's the next thing I'm going to get rid of?
The square.
Not the square, not yet.
Square root.
The 3's, the negative 3 and the positive 3, because they're not underneath anything.
Oh.
We're going to cancel these out. So now I'm left with just a square root of X squared. And then we are left with an X. So on the quiz, you can't just say it's X. Like, you have to actually show the steps. How do we get to X? All right, last question, and then we'll be finished for today. I'm going to write my G function. So this is my G function. So I have the square root of something minus 3. And the something is f of x. So underneath the square root, I'm going to put x plus 3 squared. So do you see how in my first one, the last thing that went away was my square root?
Mm-hmm.
Here, that's going to be the first thing, because we have this in parentheses and I have a square. So the first thing I'm going to do is cancel out the square and the square root, which is going to leave me with x plus 3 minus 3.
You just cancel out with one.
And then I'm left with an x. All right, I'm going to end there. Tomorrow we're going to do one graph, and then we're going to find the inverse of functions, where we have a function and we have to find the inverse.